Every day, tons of waste cooking oil are discarded, polluting waterways and creating wasted potential. At the same time, maritime transport in Malaysia depends on fossil diesel, driving up fuel costs and carbon emissions. This double challenge impact coastal communities, local industries, and our nation's sustainability goals. Conventional biodiesel production relies on thermally driven processes that consume significant energy and require complex setups. These methods limit scalability, drive up costs, and slow down the transition towards cleaner fuels. That's where the integrated Matthew Esters Blending System, or iMeBS, comes in. This innovative solution leverages proprietary hydrodynamic cavitation technology to efficiently convert waste cooking oil into biodiesel, faster, cleaner, and at a lower cost. Using controlled cavitation, iMeBS accelerates reaction kinetics without the need for external heating. The modular system integrates blending, solvent recycling, and can process up to 40 liters per batch. Better yet, it works with multiple non-edible oils, including waste cooking oil, transforming local waste into a valuable energy resource. Compared to traditional methods, iMeBS achieves up to 4 times lower energy consumption and a 6-fold faster reaction time. Its modular mobile design makes it easy to deploy where it's needed most, directly supporting decarbonization efforts in coastal and island communities. We are currently working with other 3 government-linked universities to produce biodiesel using iMeBS, with the blending and engine testing being done with our collaborators. The system reduces emissions, lowers costs, and sets a deployable blueprint for waste-to-fuel innovation that aligns with Malaysia's low-carbon and circular economy aspirations. If you're looking to partner in scaling sustainable fuel solutions, let's collaborate. The integrated Matthew Esters Blending System is ready to help power the transition toward a cleaner, more resilient future.